Hello everyone, welcome to my channel to the Logic Bites. Okay, today's DSA series as a third lecture to base on the arrays, but based on these arrays, in this lecture we can implement and to learn the basic operations of arrays and their time complexity and space complexity. So first is the basic operation of array and their time complexity. Okay. So arrays are used to store elements in a continuous memory. So common operations are used in the arrays. So first operation is travels. Okay. Mhm. So first operation is travels. In this operation, in this operation, travels to access the element to accessing the element one by one. In this travels operation, we are using the for loop. Okay, everyone everyone aware about the for loop. So what is the syntax of for loop? For initialize and then curly bracket and then written in this curly bracket we are writing the condition. Okay, in this curly brackets we are writing the condition. I hope you understand about the for loop. But if you want to traversing and accessing the elements, it is the first lecture, it is the first operation in the arrays. So, um, so we are using the for loop for accessing the element. So, accessing the element, each and every element accessing, we are using the for loop, initializing with 0 and to less than n and increment of plus plus. Then print the element array of I is the index. So index to print as to print each element each element in the array. Okay. Then what is about the time complexity? So basically the time complexity is a based on the loop. We are using the for loop and one iteration we are using. So time complexity is a bigger of n because one loop are used. If we have using the we have used the in under the two for loops. Okay, so then time complexity is big of n square. Otherwise, three for loop, then time complexity is big of n cube, and so on, so on. Okay, so but we are use only the one loop as a for loop, so time complexity is big of 1. Then second operation is the Second operation is a insertion. If we want to insert any element in this array, so we are use the insertion operation to inserting the element. Okay, so basically it is a time complexity big. Okay. Then insert the elements at index 10. This is the for loop are using for the insertion. There there in other same as the same as the same as the traversing element, traversing operation. In this insertion, I is equal to an I greater than 2 and I decrement. And this logic is simple as the previous operation. And if you want to insert any element, we can we can write the we can return a index of element. Okay, where where you where you uh, where you insert this element, then this position we can return uh, into this square bracket. Okay, so two. If I want to insert the element in the position of 2 as value is a 10, so we can return a index as a 2. Very simple operation. And third one is a deletion. Okay, deletion. Any delete. If you want to delete any data, any values in this array, so we are use the deletion, removing the element and specific index and shifting remaining the elements. So delete elements as a 2. Okay, this is the basic the formula. And in this insertion sort, also the time complexity is big of n and space complexity is a big of 1, because space complexity is big of 1 and time complexity is big of n. In the deletion also the big of n, because we have only using the one loop. Okay, and last one is a search operation. In this search operation, if uh, if uh, if you want if you want to searching any element uh, in the data in the array, so finding whether an element and exists. Okay, so it is a linear search. So sorry time complexity is big of n, like this previous operation. Hmm. So we are written this. Here we are using the one for loop. So time complexity is equal to n, and I initialize with 0, I less than n, and increment with plus plus. If array of I is equal to k, in this linear search, we are using the key variable. When key variable and array index are same, then we are found this element. Okay. Basically, these four operations we can write: time complexity and space complexity of each and every operation. So travels because of n because of 1. Insertion because of n because of 1. Operation time complexity. Deletion because of n because of 1. Insert because of n because of 1. Okay. So uh, we are here to stop my third lecture. Like any queries regard any query, if you have any queries regarding the lecture, put them in the comment box. Thank you. Thank you for watching my video.